Here we go. Okay, so looks like it's recorded. So we have to learn how to simplify radicals. Now remember, our perfect squares, this is on your factoring flowcharts, right? The perfect squares, 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And this one, I think, goes all the way up to 20. Okay? 20 squared is 400. What we're going to have to do to simplify radicals is we're going to use a property of radicals, or square roots. I say radicals because not all radicals are square roots. So we're going to have to simplify radicals. We're going to have to split them up, use the properties of radicals, and split this up to a perfect square radical times an imperfect square radical. And this gets complicated, especially when these numbers start getting big. Okay? Now, 18 is not too bad because the factors of 18, and this is why we spend so much time with factors. Okay? The factors of 18, 1 times 18, well, that's not going to really help us simplify, right? 2 times 9 and 3 times 6. Those are my factors, right? The highest perfect square that's a factor of 18, well, look, there's a 9 there, right? There's a 9 perfect square. So I'm going to break this up using the properties of radicals. I could say, hey, this is the square root of 9 times the square root of 2. See how that's a perfect square, an imperfect square? I could take the square root of a perfect square. Square root of 9 is 3, and the square root of 2, well, it's an irrational number. So I'm just going to leave it. So that's my answer for simplifying the square root of 18. Okay? Can't go any farther. I don't want you to get a decimal, because if you do a decimal, it's going to be an approximation. If somebody comes to you in your later math courses here and says, I want the exact value, I don't want you to give me an approximate answer, leave it in radical form. All right, geometry last year, most likely you probably put that in a calculator and got an approximate answer, a decimal, right? Okay. So we're going to keep doing this until we get the hang of it, right? So 48. The factors of 48, I'm not even going to use 1 and 48 because that's not going to help me. Let's see, 2 and times 24, right? Let's see, 3, does 3 go in there? Yeah, I think so. 3 and 16. 4 and 12. And 6 and 8, right? So what's the largest perfect square that's a factor of 48? Well, yeah, 16, right? 16. 16 is a perfect square. So I'm going to split this up into a perfect square, which is radical 16 times an imperfect square, radical 3. I know what the square root of 16 is. It's 4, and that's my leftover, radical 3. There's my simplified answer. Okay, square root of 52. 2 and 6. I'm sorry, 2 and 26. 3, does 3 go in there? Nope. 4? Yeah, 4 does, right? 4 and 13. 5, 6, nope. 7, nope. 8, nope. 9, nope. 10, nope. 11. I think that's it. Okay, what's my largest perfect square? 4, right? So my perfect square, square root of 4 times the square root of 13. I can take the square root of 4, it's 2, and I'm left with square root of 13. Well, what if I have a fraction? There's a couple of different ways you can do this. I like to think of this as there's a property that says I can separate these. It says I can take the square root of 4 divided by the square root of 9. And I know that 4 and 9 are perfect squares, right? Square root of 4 is 2. Square root of 9 is 3. Make sense? Question, Hannah?
When you do like the square root, is it always supposed to be the half of that number? Or what, like multiple figures?
It's the multiple of the same number. So if I go back to my perfect square, this is 1 squared, 2 squared, 3 squared, 4 squared, which means it's 4 times 4 is 16. 3 times 3 is 9. It's a number that's multiplied by itself. That's a perfect square. Okay? And then, number 5. Well, again, we're going to split this up to get the square root of 2 divided by the square root of 3. Right? Well, you're saying to yourself, well, none of these are perfect squares. Am I done? Well, no, you're not. Because just like we can never have a negative exponent, guess what? We can never have a radical in the denominator. So how do I get rid of this radical 3? Well, I'm going to multiply it by itself. Radical 3 times radical 3 is just 3. And I'll show you why in a minute. Now, I can't just multiply the denominator. I have to multiply the numerator by radical 3 too. Otherwise, I change the value of the fraction, right? If I just multiply it by 1, I'm not changing the value. So, radical 2 times radical 3, the property says, put the radical, put 1 radical and multiply the 2 times 3, which is 6. Now you have to be careful, because sometimes when we do problems like this, we'll get a radical 18 or something like that, so we have to take it steps further to reduce the numerator radical. So these problems can get lengthy. Now, let's go back and figure out why when I multiply square root of 3 times the square root of 3, I get what's inside. The square root is nothing but 3 raised to the 1/2. The square root of 3 equals 3 to the 1/2. Okay? That's what the square root means. It means that it's being raised to the 1/2. Now remember, when I multiply it by itself, 3 to the 1/2, remember what happens when we multiply with the same base? We add those exponents, right? 1/2 plus 1/2, which equals 3 to the 1st, which is my 3. Thank you. Thank you. Thank you very much. Okay, now we're going to do some variables, right? So this gets a little tricky because look at number 6. It's an equation. I have to get x by itself. You're saying, well, x is by itself. I'm not. No, it's not. It's x times x. It's x squared. So x isn't by itself, right? So to get rid of the power of 2, I'm going to take the square root of that, which means whatever I do to one side, I have to do to the other, right? Okay. What happens is that square root cancels out the power of 2. So I'm left with x. And here I'm going to simplify this radical because we have to simplify all radicals. The square root of 16 is 4. Now, you would think that this would be the right answer. It technically is not. Okay? Yes, 4 times 4 does equal 16, but doesn't negative 4 times negative 4 equal 16 too? So when I take the square root, I don't know which one I'm talking about. Am I talking about positive 4 times positive 4 or negative 4 times negative 4? So we're going to fix this issue and say, hey, when we take the square root, we actually get 2 answers. We get a positive 4 and a negative 4. This symbol tells me, hey, there's 2 4s here. There's a positive 4 and there's a negative 4 here. So when we take the square root, we really should be putting plus or minus the square root of 16. Okay? We have to do that when we're talking about variables and squaring. All right, in order for us to solve quadratic equations, right? This is a quadratic because it's x squared. It's an equation because of the equal signs. That means we have to get x by itself. That's the whole idea here, right? So I need 0 on one side, and we went through this yesterday. I need 0 on one side of my equation. So I'm going to subtract 21 first. So subtract 21. This side does go to 0. Here, and remember, keep your like terms and organized here, so your constants here. So I didn't do anything with the 2x squared. Oh wait, I did this backwards. I'm thinking factoring. I'm sorry guys. My fault. I want to get the x squared by itself, right? See, I'm thinking of yesterday. So actually, I'm going to get rid of the 3. I'm so sorry. I'm going to add 3 to both sides. I don't want 0. I want to get x squared by itself. Okay. Thank God you guys are using pencil. So my 3's go away. I get 2x squared. 21 plus 3 is 24. Did that really mess you guys up? A little? I'm sorry. I want to get the x squared by itself. It's being multiplied by 2. So I'm going to divide by 2. So I get my x squared equals 24 divided by 2. It's 12. I finally got my x squared by itself. I'm going to square root both sides. And when I do, I'm going to get my plus or minus. So I get my x equals plus or minus the square root of 12. Now, is the square root of 12 simplified? Well, if I ask you the question, chances are it's not. The factors of 12, let's see, 2 and 6. I'm leaving the 1 and 12 out. 3 and 4. Lo and behold, 4 is a perfect square, so I'm not done. So I have x equals plus or minus my perfect square is the square root of 4 times my imperfect square is the square root of 3. So x is going to equal plus or minus. Always put your perfect square first. Square root of 4 is 2 times the square root of 3. Isn't that lovely? You guys love that stuff. Fun with Math Day. Is there anybody that did do this in 2 years ago? Remember when COVID hit in the spring? No, I don't think so. I think they just completely got rid of it for that spring semester. All right, a couple more here. So, number 8, I need to get the x squared term by itself. So the first thing I'm going to do is get this whole term, this fraction by itself. So I'm going to subtract 1 from both sides. Now, if I was factoring, I would move the 8 over and have all that other fun stuff. So subtract the 1, I get x squared divided by 5 equals 8 minus 1 is 7. I got the fraction by itself, but I want to get rid of the denominator. What do? Multiply both sides by the denominator. 5. The 5's cancel. I get my x squared equals 35. To get rid of the power 2, take the square root of both sides. Don't forget your plus or minus. That cancels out the power 2. I get x equals plus or minus square root of 35. Check to see if 35 is simplified. Let's see, 2, 3. The only factors of 35, other than 1 and 35, 5 times 7, right? And neither one of those is a perfect square, so I am done in more ways than one. So you're always, with these problems, you always have to be concerned about getting x by itself. But you got to undo the PEMDAS rules, right? You're actually kind of going backwards with it. All right, number 9. I want to get rid of that 1/3, right? Think of it as a coefficient, that 1/3. So I'm going to multiply both sides by... This is all multiplication, right? Because that's a quantity. That's one number. So this is multiplication. So I'm going to multiply by the reciprocal of 1/3, which is 3 over 1, right? Or 3. Okay. These cancel. I'm left with the quantity x plus 5 squared equals 21. Now, I can't break this up. Okay, there's no way I can break this up. So, I'm going to get rid of that. I got to get rid of that power 2 in order to get inside my parentheses, right? Because we're doing PEMDAS backwards. Parentheses is first, exponents is second. I'm doing the reverse. So I got to get rid of the exponent before I work with the parentheses. Okay, so I'm going to take the square root of both sides to get rid of that exponent. Okay. Cancels out that power 2. Now I'm left with the x plus 5, and I can remove the parentheses because there's no other mathematical operations with it. Equals this, there's only 3 and 7 are the factors, so it's simplified. Don't forget your plus and minus, square root of 21. Okay, I still have to get x by itself, right? Now, I'm going to subtract that 5. So I get x equals, now these are unlike terms. So, and always put your number first, then your radical. So I have my minus 5. Don't forget the plus or minus sign. Square root of 21. There's my answer. Please remember, this is 2 answers. Just like when we did yesterday, most of our problems when we solve quadratic equations by factoring, we got 2 answers, right? X equals -2, 5, whatever it was. This is, and technically this is x equals -5 plus the square root of 21, comma, -5 minus the square root of 21. So it crosses my x-axis, right, at two points. It has 2 x-intercepts. This is just a shortened, condensed version of it. Just keep this in the back of your mind. This is 2 x-intercepts. All right, number 10, my last one here. This time, I'm going to get rid of the 5. So I'm going to divide both sides by 5. So I get x minus 1 squared equals 125 divided by 5 is 25. Going to get rid of the power of 2 because I have parentheses. So I'm going to square root both sides. Cancels out that power of 2. So I get x minus 1 equals, now 25 is a perfect square. It's 5 times 5, right? So the square root of 25, don't forget your plus or minus. Plus or minus 5. Still have to get x by itself. Going to add 1 to both sides. Now, it's a little tricky here because these are like terms, right? But don't forget, 1 plus or minus 5 is 2 points. You have 1 plus 5, which is 6. 1 minus 5, which is -4. So here's my 2 x-intercepts. If you can simplify and combine like terms, do it.